Good morning. I'm Nandini Kungani of CSCB, and today my topic is about encoders and food and beverage. So before we start about how do encoders play a role in food and beverage, let us know what is actually an encoder. An encoder, it is a combinational circuit that converts binary information in the form of a 2 to the power n input lines into n output lines, which represents n-bit code for the input for simple encoders. It is assumed that only one input line is active at a time. As an example, let's consider octal to binary encoder. As shown in the following figure, an octal to binary encoder takes 8 input lines and generates 3 output lines. So if there are 2 to the power n input lines, then there is only one output line. Now that is an encoder. And as an example of an encoder, we have considered an octal to binary encoder. As the name suggests, octal to binary refers when you give 8 input lines, there are only 3 output lines. Because 2 to the power n is equal to 8, so n will be equal to 3. So 2 to the power 3, so 8 input lines, and there'll be only 3 output lines, where n is the number of the output lines. So an encoder is nothing but a combinational circuit that converts binary information, which is in the form of 2 to the power n input lines into n output lines. And here you have taken a octal to binary encoder. Now, how does an encoder work? Encoders use different types of technologies to create a signal, including mechanical, magnetic, resistive, and optical. Optical being the most common. So they use a lot of technologies in order for them to work. They use mechanical, magnetic, resistive, and among all of them, they most commonly use an optical technology. In optical sensing, the encoder provides feedback based on the interruption of light. The graphic at right outlines the basic construction of an incremental rotatory encoder using optical technology. A beam of light which is emitted from an LED passes through the code disk, which is patterned with opaque lines, much like the spokes on a bike wheel. As the encoder shaft rotates, the light beam from the LED is interrupted by the opaque lines on the code disk before being picked up by the photodetector assembly. So as I've told you, they use optical. The optical technology is most commonly used for working in the case of an encoder. They basically use the optical sensing method for the working of an encoder, where you will have a code disk which is blocked by opaque lines like that of a bike wheel. So as the encoder shaft rotates, the light beam from the LED, it is interrupted by the opaque lines on the code disk before being picked up by the photodetector assembly. This produces a pulse signal. This whole process of photosensing, it produces a pulse signal. So when you get a light, then that signals it is on. And when you do not get a light, then that signals that it is off. So light is equal to on and no light is equal to off. The signal is sent to the counter or the controller, which will then send the signal to produce the desired function. Whatever the signal is produced, that is, if you get a light, then it is on, and if you do not get a light, it is off. So whatever pulse signal which is produced after this optical sensing, it will be sent to the signal to produce the desired function. It will be sent to the counter or the controller. The signal will be sent to the counter or the controller to produce the desired function. Now, how does an encoder work? That was the theoretical part of it. If you see the diagrammatical part of it, then it somehow looks like this, where we have an electronics board, we have a photodetector assembly, we have a code disk, we have a light source and housing assembly. So this particular light source will be blocked by all these opaque lines on the code disk. So when you get a light, then that means it is on. And when there is no light which is being shown, then that means it is off. So you have an electronics board. This is a photodetector assembly, which is upon the code disk. The code disk will consist of many opaque lines, just like a bike wheel. So the light source can be an LED bulb or any other light source as you prefer. Whatever light will be emitted from this LED source will be blocked by these opaque lines on this code disk, which will be detected. Before taking into the photodetector assembly, it will be blocked by them. So when you get a light, then that means it is on. And when you do not get anything, it means it is off. This whole process of sending the light through this code disk is known as photosensing, which is one of the most famous technologies which is used for an encoder in order for an encoder to work. Now, what are the applications of encoders? There are some of the applications for the encoders. Numerous of them are there, but few known and noted ones are encoders are used in aerospace. They're used in packaging. They're used in filling. They're used in food and beverage. They're used in printing. They're used in stagecraft. They're used in textiles, XY positioning, material handling, etc. So these are just a few of the applications of the encoders, wherein we note that encoders are a very important application of the food and beverage because of its working towards it. Now, encoders in food and beverage. When you specifically talk about the application of the encoders in food and beverage, it is like this. Machinery in the food and beverage manufacturing industry includes a wide range of operations such as processing, filling, packaging, material handling, and labeling. These are some common applications when you consider any kind of food and beverage that is being packed. For example, if you consider Coca-Cola, then it needs processing and you need a machinery for that. It needs filling into the bottles, which is done by another set of machinery. It needs packaging, that is packaging the bottles. It needs material handling and also labeling them with the brand name. So all of these are few processes which are very common in all kinds of food and beverage industries. So you need a different set of machinery for that. And depending on the particular stage of the manufacturing process, as well as the operating environment, encoders in food and beverage manufacturing may need features such as stainless steel, housing, high or low temperature rating, or IP67 environment sealing. So in all this kind of machinery, like for each different process, in each stage of process of packaging, filling, processing, material handling, labeling, the machinery we have will consist of encoders, which will have a certain set of properties on the basis of which kind of process, in which stage of the process is the food and beverage thing is there. So few examples of that attributes are stainless steel, housings, high or low temperature, and IP67 environment sealing. Now, some examples of encoder applications in food and beverage manufacturing includes filling. There are inline fillers, auger fillers, peristaltic fillers, rotatory fillers, and which are all a basis of an encoder. So when you go with the filling process, then you have all such kinds of applications in case of encoders. Now, if you go for motor feedback, then you have capping, bottling, processing, etc. And when you go with conveying, there is metal detection, inspection, machine feed systems, etc. When you go with registration mark timing, there are pick and place robots, rotary tables or filling, bottle labeling, XY positioning stream, pick and place robotic. So in different kinds of streams or in different kinds of fields, you have different kinds of applications which are as shown in this slide. Now, what are the merits? Why do we exactly use encoders in the field of food and beverage or in other kinds of fields? Because they possess some of the merits which are unique. And these are the listed merits of them. They reduce costs. So encoders, they basically reduce the cost of production, or they basically reduce the cost of the entire processing. And they also save time. Their flexibility over production is another added merit in this field, and it improves diagnostics or condition monitoring. Thank you.